Well, good evening, boys and girls. Tonight, I'm going to talk to you about, I'm going to give you two videos. The first is about the determinant of a matrix. And the determinant of a matrix is a number that's associated with a square matrix. And by square, I mean that there are the same number of rows as there are columns. So this is a 2 by 2, hence a square matrix. So how do I find the determinant of a square matrix? Well, I will tell you. So here we have a square matrix, A, B, C, and D. What we want to do is we want to find the products of the diagonals. So first we go upper left to lower right. So A times D minus the product of the diagonals in the other direction, minus B times C. And then we have the determinant of our matrix. So let's find the determinant of a 2 by 2 matrix. We'll throw some numbers in. 2 by 2. And let's keep it simple. 5, 4, 3, and 1. Okay, first what we're going to do is we are going to find the product of the diagonals going upper left to lower right. So we have 5 times 1 minus, and then we're going to find the product of the diagonals going in the other direction, 3 times 4. So we have 5 minus 12, or negative 7. So the determinant of this matrix is negative 7. Now you may ask yourself, why do I care about this determinant thing? The determinant is very useful when trying to find the solution to a linear system. And if you don't recall a linear system, I will refresh your memory. AX plus BY equals M, and CX plus DY equals N. So there's a linear system, and we can use a determinant to find the solution for X and Y. And that big revelation will come in the next video on Cramer's rule. So finding the determinant for a 2 by 2 matrix is pretty straightforward. However, what do you do if you have a 3 by 3 matrix? Well, I'll show you. So if I have the determinant of A, B, C, D, E, F, G, H, I, how do I find the determinant? First thing what I want to do is I am going to make 2 more columns, repeating the first 2 columns. A, D, G, B, E, H. Okay. Now I'm going to do what I did in the first place. I'm going to do A, E, I plus B, F, G plus C, D, H. So I'm going to find the product of the elements on these 3 diagonals, add them together, and from that I am going to subtract the products on these 3 diagonals, G, E, C plus H, F, A plus I, D, B. And that'll give me the determinant for this 3 by 3 matrix. Excuse me. Alright, I am going to erase all this, so you might want to pause it, and I'm going to do one with numbers. I guess I don't need to erase it. Let's do one with numbers. So let's find the determinant of 2, negative 1, negative 3, 4, 1, 0, 3, negative 4, negative 2. And the first thing I want to do is I want to repeat the first two columns right next to the third column. So 2, -1, 4, 1, 3, -4. Okay, let's find the product of these three diagonals and add them together. And check my math. So let's see here. I've got 2 times 1 times -2 plus -1 times 0 times 3 plus -3 times 4 times -4 minus, and I'm going to now subtract from that the products of these three diagonals. So minus 3 times 1 times -3 plus -4 times 0 times -2 excuse me, plus -2 times 4 times -1. Okay, so I have the first sum. 2 times -2 is -4. So I have -4. -1 times 0 times 3 is 0. -3 times -4 is 12. 12 times 4 is 48. So I have -4, 0, and 48. I add them up and I get 44. And from that, I'm going to subtract the sum of this. So I have 3 times -3, or -9. -4 times 2, or -8. -2 times 4 is -8 times -1 is +8. And look at that, I made quite an error here. I said this is -8, but we all know that should be 0, because anything multiplied by 0 is 0. So I have -9, 0, and 8. That gives me -1. 44 minus a -1 is 44 plus 1, or 45. So that is the determinant of that 3 by 3 matrix. Now, you may ask, why would I want to do this? Because this seems like an awful lot of work. And why, I ask myself, will this not erase? Because it really should. Okay, hold on a second. Let's see here. It's just not erasing. Okay. Okay. I couldn't get that last slide to erase. So I'm going to have to do it on here. But before I do this final problem, I'm going to let you read this cartoon. And I thought it was apropos because some people do think of math class as HE double hockey sticks. Ha ha. Okay. So a 3 by 3 matrix. We can use that to help us find the area of a triangle. So the area of a triangle can be calculated as plus or negative 1/2. And the plus or negative is there because use whichever sign makes your answer positive, because you really cannot have a negative area. So here I have a matrix. And here I have a triangle. Pretend that's a straight line. Pretend they're all straight lines. This is x1, y1. This is x2, y2. And this is x3, y3. So the way we would set up our matrix is we would go x1, y1, x2, y2, x3, y3. Okay, this is a 3 by 2 matrix, but to find the determinant, I need it to be a square matrix. So in the last column, I toss 1, 1, 1. Now before we can find the determinant, we need to repeat these two columns next to our matrix. So let me just do that down here. So I have x1, y1, 1, x2, y2, 1, x3, y3, 1. And next to that, I'm going to put x1, y1, x2, y2, x3, x3, y3. And I am going to then multiply down my diagonals, just like I showed you in the previous example. I'm going to add those three products together, and from that I am going to subtract the sum of these three products. And so when I do this, it'll look like this. I will have plus or negative 1/2 times x1, y2, 1 plus y1, 1 x3 plus 1 times x2, y3. From that I will subtract. I will subtract x3, y2, 1 plus y3, 1 x1 plus, I'm going to do a little angling here, 1 x2, y1. And there you have it. So that's your first video for the night. And there are no problems on here for you to try, because I will put those on at the end of the next video, which talks all about Kramer's rule.